Hello friends, we are going to learn a few things about artificial intelligence in this series. We'll begin with the first module. Let us try to understand what artificial intelligence is all about. In my own definition, artificial intelligence is about writing difficult programs. Difficult programs? You probably may think, yeah? Yes. Well, difficult program does not mean that something which is very obscure, something which only top flight people can write, something which can only understood by top most intelligent people. No. Difficult means in this artificial intelligence parlance, something which is not possible to be done by computers, which is something very easily can be done by humans. For example, my 4-year-old daughter can recognize a car looking just at a new car. Maybe, for example, if she looks at Maruti van, then she looks at say sedan, and then suppose Maruti 800 car passes by, she would recognize it to be a car despite being very different from what she has seen already. So can a computer program do it? That's a question that we would like to answer. And that's what we mean by studying artificial intelligence, how to make computer do things which people are better at times. Let us try to understand one more thing. For example, if you meet a friend after many years and the friend has grown in all dimensions, you still are able to recognize him. How do you do that? Have you ever thought of it? You probably ask your own self, you don't really know how have you done it. But then if you want a computer program to do it, how can you write a computer program to do it? That is what artificial intelligence is. We are going to study a few things about artificial intelligence in this module. In fact, we will just begin with introduction to artificial intelligence. We'll talk about what it set out for and what actually it has achieved so far in this particular module. So let us begin with some of the problems that I already mentioned out. I call them the problems with special attention. Why it is hard for computers to solve these problems? Let me repeat that computers are not designed to solve these problems. They are designed using something called von Neumann architecture, where there are processors and very fast processors. They execute things in sequential fashion. Unlike that, human brain is equipped with neurons. There are 10 raised to 10 neurons with 10 raised to 14 interconnections, dynamic interconnections. They are typically vision related, audio related, and require highly parallel processing. Those things are possible to be managed by brain. Computer processors, on the contrary, are not all that good for such highly parallel processing. Human brain stores information in a very different form than computers do. For example, I just ask you a question, that there is an actor, a Hindi cinema actor, about 70 years old and have a white beard and wear specs. You can immediately recollect him to be Amitabh Bachchan. Can I write a computer program which can do it? People tried mimicking, but it's really very hard. Or, for example, I play a few bars of music and immediately after that you realize it to be Avara Hoon or whatever. Okay, something. How did you do that? How have you, say we have huge database of songs and we have a lot of other information related to songs with us, and we just hear some part of the music, some part of the song that we are required to recollect, and we get it. How are we doing it? AI is about writing programs which can mimic human brain functioning, which can solve programs, which can solve problems which human brain is capable to do. Okay, so let us look at some of the definitions. Elaine Reach, in one of the popular book of hers, says the AI is study of programs at which at the moment people are better. One more author puts it at AI is the study of programs or building entities which can understand, perceive, predict and manipulate like humans do. Fine. You read a book, new book, and you will find new definition. There are hundreds of definitions around, and no definition is 100% correct. Because defining intelligence itself is very hard, and defining artificial intelligence is one step further. It's very hard. So, fine, we will not try zeroing on a definition right now, we will try to understand what we mean. In fact, let me repeat that I am going to talk about difficult programs and not intelligent programs. For example, if you want to write a program which let the robot brush something, do you think it is an intelligent thing? It does not seem to be. But if you don't know how to make sure that robot does not press the toothbrush too hard, it's going to break. Or for example, picking up a chalk stick. Such things are pretty hard for a programmer to program with robots. Think of a robot playing table tennis. Can you write a program? In fact, nobody is yet successful doing so. Why? Because it's very hard. Why it is so hard? Let us try to understand why it is so hard. In fact, AI is set out with that thing in mind. It will like to mimic human, like to make sure that the computer programs can do intelligent things like diagnose a disease, or play table tennis, or play chess, or something like that. Some of the goals are achieved, some of the goals are not. Why? Okay, it is because the computers work very, very differently than the human brain. Human brain is designed to play with analog signals. Human brain is designed to work with inexact, incorrect, incomplete information. Computer programs are not. Okay. If you want to make computer programs do something which is similar to human, we need to learn things, techniques called AI techniques. AI techniques are the techniques which make computer programs work like human being. Okay. We'll study about AI techniques next, but before that, let me tell you why one should study AI. It started in 60s and it was designed to make sure that people, it was designed to make sure that the computers can do something which humans can. And in the initial run, there was a lot of enthusiasm about everybody. People wrote programs, people execute them, and there was some success as well. But then it couldn't do what it should in a very long journey, 50 odd years so far, but it couldn't do what it set out to, because of the problems that we are going to discuss. But then it is not dead, neither it is not completely failure. AI, though we are not able to write programs which can actually do exactly like human being, but then we have programs which can recognize signature, we have programs which can recognize photos, we have programs which can talk to human being in a semi-human way, and so on. So we are successful, and in fact some of the very, very important problems are solved, which we'll see in the journey during our discussion about AI. Okay, so I just said we have something called AI techniques which we would like to implement in programs. What are they? Let us talk about first thing about whenever you try writing an AI program, there is no algorithm. For example, if I ask you, how have you recognized your friend? How do you know? You cannot answer because there is no algorithm. Okay, if you are playing chess and you do something and win, if I ask you what was the algorithm that you were following, you look for it and you won't find it. AI programs have no algorithms. The first technique, AI technique, is to find a way out when there is no algorithm. If your program is capable to do something like that, yes, the program is capable to execute an AI technique. The second problem, sometimes we have algorithms, but then the algorithm has to meet with lot of combinations and permutations which algorithm cannot complete in the real time. For example, something called a traveling salesman problem. If you want to find out shortest path for a 25 city case, a traveling salesman has to move around and find shortest path between those 25 cities. If you just use conventional computing technique, the program cannot complete in the salesman's lifetime. So that's something which is pretty hard. Permutations and combinations. The algorithm is pretty simple. You'll have to find the shortest path. So algorithm, you can write an algorithm for it, but the algorithm will not be able to complete in time, in the real time. So that's the problem. One more thing, I just talked about chess. If you're playing chess and if you think that I'll have to find out all possible moves till the end of the game, and if you write a computer program to do it, and if you pick up the best microprocessor, best supercomputer in the world, and give that supercomputer the program to calculate all possible moves from the beginning to the end, the supercomputer itself cannot do it, probably till 100, 500 years or so. So that's the problem. The number of permutations are high. So the second point about AI technique is to find out something which can handle this combinations and permutations. Sometimes, that's the third point which I'd like to mention, is that in many cases we don't really want best answers. For example, if I go out and park my car somewhere, I'm not going to look for the best parking place. I'll just find out a place which is good enough for me to park my car, and I'll do it. If I want to go to a restaurant, I won't just find out the best restaurant in the city. I'll just get a restaurant which satisfies minimum of my needs. If I'm going to a movie, I won't be going for the best movie in the city or best actor and so on and so forth. I'm not looking for that. Most of us are not looking for best solutions. Most of us are looking for solutions which satisfy the minimum of some criteria that we have in our mind. Okay, so that's the other characteristic of an AI technique. If you want to have something which can do this, it's really great. Okay, and one more thing, the conventional programs don't have learning component. How humans do things, how do they learn doing things? They learn doing things by working on it, practicing it, and becoming better. Can we have computer programs which can do it? If we have computer program which can learn on its own, we don't need programmers. Okay. For example, if you just give a program to an accountant, accountant does his job, and program learns how to calculate accounts, and so on and so forth. You don't need programmers, but it's impossible. The learning component is something which is a very, very hard thing to build in. Okay, anyway, but the AI techniques that we are going to study later will see some way to make sure that the computer program learns. Okay, one more important thing. For example, if I give you a computer program which is an AI program which can mimic a doctor, and it just looks at your symptoms and diagnoses that you have a cancer, will you believe him? You will not. Why? Obviously, nobody would believe this unless you're given sufficient evidence. That is called explanation. It should. Or for example, let us not talk about cancer, but suppose if I go to a doctor and doctor says you have malaria, then I would ask why. He would say you have a cold, on alternate days you have fever, you feel weakness, and most probably your blood report says so. Then I would accept him. Can a computer program explain its reasoning? Can a computer program explain its results? If it is so, it has more chances of being accepted as an intelligent program. Okay, so this is one more thing which an AI technique should do. Okay, how it is done? Okay, for example, one thing which is very, very common in almost all AI programs, across all AI programs, is called heuristic based search. Now, what is heuristic? Heuristic is a rule of thumb which help us shorten number of options. For example, if you're playing chess, you won't be thinking of all possible chess moves. You will only be looking at a few one. Why you did that? Because there is something which is running in back of your mind. For example, you want to have a control on the central part. You want to have, for example, capture the king of the other side, called check, or something like that. So you know which moves are better compared to others. That knowledge is heuristic. So if you have heuristic, you know which moves are better compared to others, and you can take those moves and win the game or do it better. Okay, so that is what heuristic is all about. In fact, heuristic is about domain knowledge. How do you gain domain knowledge? How do you become an expert? I've already told you, if you are a human being, you can become expert by practicing it. Okay, so but then you're not only practicing, you're also accumulating the results of your experiment as rule of thumbs in your mind For example, if the opponent is playing X, you know that this is going to be dangerous and you are more cautious and you know that you will have to play Y to save yourself from it, because that is the experience told you. If you do that, that is an example of using a heuristic. I give you one more example. For example, if you are thirsty and if you say climbing hill, you will not go up, you go down. Why? Because it is more likely to find water down hills. So, that is a heuristic. Okay. So, these are examples of heuristic. Second point, when we are talking about AI techniques, the other thing, how you store this information and how you infer from it. For example, there is a Prolog program. Prolog is a language which is very, very powerful, very useful in artificial intelligence domain. You can see on the PPT that there are three predicates. One is mother, Devaki, Krishna. Second one is brother, Kans, Devaki. And third one is mama XY if brother XZ and mother ZY. Now, if you just look at this, you can easily convince yourself that you can prove that Kans is a mama of Krishna. Now, that is called inference. The first three steps describe data, knowledge, and what we have proved is called inference. So, how do you store information and how you achieve something out of it is what is needed in AI technique. Okay. There is something else called frames. In fact, predicate logic is one way of representing knowledge. The other one is called frames. Most of us who study C++ and Java and the languages like that know that these languages are storing information in the form of object oriented representation. When we store information in object oriented representation, we describe things in form of class and object and so on and so forth. So, frame is very similar to that. In fact, frame is a predecessor to object oriented programming. And if you study little more about frames, you know that frames, when frames were designed, there was no notion of object oriented computing, it came later. Anyway, one more area which is growing today, they are called software robots or bots, and there is something called mobile agents. In fact, when I was doing my PhD, I wrote an intrusion detection system where there were robot sitting on my machine, and then which travels over the network, sit there on the other machine, gather information and so on and so forth. Now, that is called mobile agent. In AI, lot of techniques are designed which allow mobile agents to move across the network, go to the other end, gather information and collect them at a remote place. So, those are again very, very powerful mechanism of representing and processing knowledge. One more important method of doing it is using some form of entity relationship diagram. It is not the ER diagram that we generally use, but something else. There is something called semantic network. Semantic network is about connecting entities in a semantic way, meaningful way. So, it contains entities and some relations between them. We will study about them later. So, there are many ways of representing knowledge. The computer systems need to provide. Now, how these things are to be provided, how you represent knowledge, how you infer, it requires one to really develop a model and do that. Anyway, we will be studying about expert systems later, where we delve deeper into this and we will study this thing in more detail. One more very important attribute of an AI technique is to reason with incomplete information. Now, that is not that easy. For example, sometimes you need to guess. For example, if you are playing cards, you do not know what is there in the opponent's hand. How do you know? In fact, you do not know, and you will have to guess and then play and then refine your guess and so on and so forth. So, that is one example of incomplete information. But then there are a lot of other cases. For example, if you are watching a cricket match and find your friend and you just see his side face, You do not have complete information, but your database, your knowledge base and your inference engine is so powerful that will match with the features of the friend that you have seen already, you stored in your database, extract that information and say that he is your friend. So, you reasoning with incomplete information and you still able to answer. For example, let us tell you one more thing which example, okay, suppose if you get a new phone and you want to set an alarm, you do not know the options, but then if you look at the options, for example, it has phone and a few other settings and all that, you probably look for phone or look for settings. But you won't look for say profiles, you know that it is not going to be there. How did you know that? You have incomplete information, but you still know how to reason with. You go through phone and probably you will find. Okay. So, that is about working with incomplete information. The AI technique also are capable of working in a fault tolerant way. What do I mean by fault tolerant way? Suppose if I am providing information which is less than I provide information which is partially incorrect. For example, I have a friend who told me that he lives in a society called Ratlam society. I just heard that thing over phone. I was looking for that society. I asked Panwala where this Ratlam society is. The Panwala says there is no Ratlam society nearby, but there is a Satnam society nearby. How could that Panwala find out the real answer? I have not provided him correct input, but the Panwala could get that. How? Because his mind was capable to process the incorrect information and get the correct answer. Are we able to do that? Are our programs, all of us are able to do that in fact, but can our program do it? Can my database, suppose if I have a database, I have indexed my database on customer name, but if I provide an incorrect customer name, can my database return with right customer data? Think of it. If you can do that, if the program can do that, it's exhibiting AI technique. Okay, that's one point. The other thing is, okay, for example, I go to a class, school kids, and I pose a question. There is a big fish with periodically comes out of water and breathes air, have lungs and so on and so forth. Then somebody would say, I think you are talking about well, but sir, it is not fish, it is mammal. How could that student's brain do it? Incorrect information processed and the correct answer is got. A school kid, I am not talking about somebody who is very, very intelligent. Okay. But then even in that case, it is possible for a school kid to get the correct answer. So, this is the example of AI technique. Let me quickly recap what we have learned. AI is the discipline where we have learned how to write difficult programs, and difficult does not mean intelligent. Difficult means something which is hard to program because of the very architecture of the computer itself. The difficulty of the programs lie in their inability to act like humans. They have to use heuristics to search. In fact, if they don't, they'll entangle themselves into something called combinatorial explosion, a lot of combinations and permutations. Okay, they cannot search blindly. In fact, they need explanation facilities, they need to work with incomplete information, they need to work with incorrect information sometimes, and so on and so forth. There are something called neural network based methods which we will be looking at later in probably the module 9, and well, we see how they actually can be this much fault tolerant. These techniques which enable to program have all these things, and some of things in most cases are called AI techniques. Okay, we will study many of them in due course. Thank you.